Welcome to chemistry lesson number 21. Electrochemistry. Electrochemistry is the chemistry involving the study of the relationship between electric current and chemical reactions. Reactions that result in the production of energy on one side and energy resulting into a chemical reaction on the other side. In this case, we will find examples in a torch battery. A torch battery has some chemicals inside it. On one side, positively charged, and on the other side, negatively charged. When we connect a torch battery, the negative side connected to a positive side, and a bulb, it produces some light. In this case, chemical reactions produce electric energy, and examples are seen here. When you switch on the button, light comes out. This is an example of a relationship between chemical reactions and energy. On the other side, when we have a car battery, equally, it has a positive terminal and a negative terminal. When they are connected to using external circuit using wires, a car is then immobile. When a car battery shows a sign that is green, it implies that the car battery is fully charged. As you continue to use the car battery, the green color fades to an orange color, brown, and ultimately the red, implying that the car battery needs recharging. During recharging, electric current is allowed to pass through the battery, causing some chemical reactions to take place. When we are studying this kind of process, then we are dealing with electrochemistry. In this case, there is hence the transfer of electrons. Electrons move from one point to the other. Considering a reaction between magnesium and hydrochloric acid, when such a reaction takes place, we refer to it as a chemical reaction, and it is given a simple denotation of a cell. If we write the ionic equation of that reaction, the process, we have magnesium ions combining with hydrogen ions to form magnesium ions and hydrogen gas. This is a full cell. It is a complete reaction. Separating these reactions into two, we have magnesium metal becoming magnesium ions. In this case, therefore, the magnesium loses 2 electrons, becoming magnesium ions, and that is therefore half of the reaction, which we refer to as a half cell. On the other side, the hydrogen ions gain 2 electrons, becoming hydrogen gas, and this is the other half cell. If we combine the two, we get a full cell. There is therefore electron transfer from magnesium metal to hydrogen ions. Connecting these ones using a wire, we get a full cell which we can use for practical purposes, e.g. lighting up in a torch battery. The magnesium ions are got from magnesium. The magnesium, losing 2 electrons, becomes magnesium ions. They are therefore said to be oxidized. And the process is oxidation, which in short is simply the loss of electrons given a mnemonic of oil. Oxidation is loss of electrons. On the other side, the electrons that were lost from magnesium were taken up by hydrogen ions. On taking the electrons, the hydrogen ions becomes hydrogen gas. They are said to be reduced, and the process is reduction, defined by simply a gain of electrons. The hydrogen ions are therefore said to have gained electrons to become hydrogen gas, the process being reduction. Taking another example, magnesium reacting with copper 2 oxide becoming magnesium oxide and copper. Magnesium gaining oxygen becoming magnesium oxide. Addition of oxygen is oxidation. If we take magnesium and then moving from magnesium oxide in ion form, that is oxidation. Copper oxide losing electrons becoming copper metal. Loss of oxygen is referred to as reduction. So in this case, we have oxidation process and we have reduction process. Reduction being the gain of electrons, while oxidation being the loss of electrons. And this process, therefore, involves the transfer of electrons. Iron metal losing electrons becomes iron 2, written as represented here. The iron 2 so obtained can also lose electrons, becoming iron 3. The chlorine atom gaining an electron becomes the chloride ion. The oxygen atom losing electrons, rather gaining electrons, becomes reduced. So these two processes are reduction, while these two are oxidation. Oxidation can therefore be defined in terms of oxidation numbers. What is an oxidation number? The number assigned on a neutral atom, e.g. on a nitrogen, is its oxidation number. In this case, electrically neutral and therefore 0. For calcium, also it's 0. So the oxidation number in neutral atoms is a 0, implying they are electrically neutral.